You may have heard of studies where scientists scan people's brains and report that certain regions light up. But what does that really mean? To find out, we visited Columbia University's Neurological Institute in Upper Manhattan. In the basement is the Program for Imaging and Cognitive Sciences, which is where their fMRI machine lives. Ted Yanagihara is an MD PhD student at Columbia University.
Yeah, so I'm going to be getting scanned today, so Jack's going to be in control of the scanner.
Jack Grinband is a research fellow here, and Ted has done this many times before.
So I've had at least 30 different sessions in the fMRI, both for my own experiments and then for other people's experiments. Yeah.
Today we're going to see how Ted's brain responds when he's shown a flashing picture of a checkerboard. The fMRI machine doesn't use radiation. It's not an X-ray. It actually uses magnetism to track the flow of oxygenated blood. The idea is that the cells that are working harder need more oxygen.
It's the same thing as like if you're going to go exercise and your muscles need more energy, and so your heart pumps faster to bring that energy to your muscles. It's the exact same thing in your brain. Whenever you're thinking about something or even not thinking about something, just looking at pictures viewed on a screen, your neurons actually have to activate so that you can take in that sensory information. And so whenever they become active, they need more energy. And so more of that energy is shunted towards those cells.
So by mapping blood flow, researchers can begin to infer what parts of the brain are important for what types of information processing.
The mirror is in order for him to see the projection screen, and I just want to make sure that it's centered for him. Can you see both of my hands, Ted?
Yes, I can.
Great. So I'm going to give you a blanket.
Now that Ted's strapped in, we head down the hall to monitor what's happening in Ted's brain.
Okay, so we're going to do a quick localizer scan. This will give us a rough idea of where his brain is.
So here's Ted, and here's his brain.
There's his eyeballs right there. You can see the nose right there. How you doing, Ted?
Good.
Okay, ready to start?
Yes.
And we've started the scan. Each one of those is a different slice of the brain, and it's going from bottom to top.
Meanwhile, Ted is seeing this in the mirror.
What we should be able to see is that flashing checkerboard increasing brain activity and increasing blood flow to the visual cortex.
A real scan takes about an hour, but we got some quick and dirty results in about 5 minutes. Grinband zooms in on the visual cortex. That's what the screen circle is, and here's what we see.
These slow increases, that's the increase in blood flow when Ted was looking at the flashing checkerboard.
The flashing checkerboard is moving, so when it appears in Ted's mirror, there is an increase in blood in the visual cortex of Ted's brain, up and down, as the board goes in and out of his field of view. Grinband says that most thought processes take lots of parts of the brain. You don't just see one area light up, you see many. There is one area of the brain, however, that can't be imaged.
This is where I keep all my secrets.
Yeah, right.
Yeah, what is that black spot?
This is right above the sinuses, and the air-water interface creates an artifact, and so we actually can't image anything in that area.
So it would be smart to keep your secrets.
Yeah, it definitely would.
Yes.